All right, here we go. Let me just set up some things here. A little behind schedule. All right. Welcome everybody to a sunny Tuesday. Let me just finish setting up my stuff here. Trying to get that book open. All right. We are today mainly talking about other base value systems. Let me get my writing app ready. In the meantime, we can check if everyone can see and hear me. That'd be great. Can I get confirmation from anyone that you can see and hear me, please?
Can see and hear you.
All right, awesome. Let's do it. Oh, I don't have a pen. Hold on. On fire today. Let's see, where are we? Okay, so all right. So we start the next section with the one-hand system, which I tweaked a little bit to have it more be in line with the rest of the systems we're doing. It's not actually how they did it exactly, but it's okay. Where we are counting really in groups of 5 with symbols to represent uh, the different groups of 5, rocks being the single unit, then fingers, groups of 5, hands, groups of 25, 5 fingers, and so on. And then we stop it before it gets out of hand. Then building on that, we very quickly realize that we don't need this many symbols. We can have the dedicated places for the different groups of 5 and then simply indicate how many rocks, how many fingers, how many hands, how many feet, and so on, and recycle those indicator digits. Just give me 1 second, I'll be right back. Okay, so as I was saying, we then cross over from the one-hand system to something that's not super familiar, but we are inching towards the decimal system, where we use this. Well, let me go to the timeline here. There's the timeline here. You could use any one of these. We could have used first century symbols or 9th century symbols or whatever. I just like the look of these 11th century ones, but really they evolved slowly to the ones that we have today, while still counting in 5 to keep things different, keep us on our toes. We have these symbols to indicate how many ones. 0, one of them, sorry, how many rocks, how many fingers, how many hands, and so on. And we can recycle these Devanagari symbols. which eventually evolved to the digits that we have today. All right. So let's see where we should start with some problems. Possibly go over 7.1, 7.11. We're in chapter 7. Where are the problems? 7.10. Ooh, that is far. 7.11. Now 7.10 is just for fun, uh, where I pretend there's some alien language that follows a similar place value system. I do think there's a typo in that one which creates confusion. Let me just think for a second. Something looks weird. I know one version had a typo in the list of these alien words. So you see here that in 710 we have words to indicate these digits in order OB, so that has to be 0. No, sorry. In which, so we have our alien document in which sum 1, 2, 3, 4, so on counting is done. So OB would be 1, and then fin would be 2, and mus would be 3. And then the next one you see is a double digit number, OB na, which means one group of whatever and 0 left over. So that means the na is 0. But as soon as I get to 1, 2, 3, the next one is a rollover to one group of whatever it is, and therefore the group size has to be 4. So this is a base 4 system. And then the only confusing bit here is that there's a typo in here. The next one should be 1, 1, so it should be OB, OB, and then 1, 2, and then 1, 3. There's a typo in there, I apologize, which makes it not consistent with a base value system. But that question was just for fun, so I apologize for the typo. Hopefully it didn't keep you up at night, but there it is. So we'll do, I don't necessarily want to jump here. I want to progress a little bit. So let's just check if there are issues with the one hand system, with the, like if I look at problem 7.3, 4, 5, and so on, slowly build up from the one hand system, how it evolved into this in between, historically speaking, base 5 system where the symbols are a little bit different perhaps, but we are doing the same counting in fives, and eventually we can evolve the symbols to ones we have today. Then to indicate that we are working in groups of 5, we have to write the word 5 at the end. Otherwise, it'll look like our decimal numbers, and this is not a decimal system. So it's almost better to use more foreign-looking symbols. When I use my familiar symbols in a different base system, it actually becomes worse. So we have these varieties of the same underlying, underneath the surface, the same base 5 system, different versions of the same thing. So I just want to double check that before we go to 711, which then mixes it up to any kind of base. We have to make sure about base 5 first in whatever version. And we can do arithmetic in all of these versions, which is actually not a bad idea. But let's just stick to base 5 for the next little bit. Okay, so let's see here. On the exam, are we able to write our own key? Meaning if our, I guess, the Devanagari numbers, can we write one? Can we write one the top of the page what we write it as.
Let me explain that again.
Sorry,
Sorry.
yes. Or you can just speak.
Yes,
That'd be way more efficient.
I am talking about the Devanagari numbers. I
Yeah,
just couldn't go back and forth between my pages. What I was saying is because the numbers for 1 and 2 are very similar. If in our
totally.
handwriting they look too similar, are we able to show you at the top? Okay, for me this is what my 1 looks like, and for me this is what my 2 looks like.
Oh, sure.
So
Just
you
as an
know,
extra
oh,
safety. Yeah, it's a good idea.
okay, thank you.
Yeah, yeah, for sure, for sure. Yeah, the main challenge is to make them look recognizably different, I'll say. But no, totally understand that that issue. That would definitely help. Yeah, anything you can do. Yeah, totally. Was that your whole question? In 717, there was no solution given. Problem 717?
Yes, problem 717.
Again,
You
I
only
think.
go in your answer key, it goes A, B, C, D,
Oh,
except there is 1 to 5 on
oh,
there.
there's
So
not
you
even a
missed,
nice little
uh,
subscript 5 there. 10 there.
yeah, so you missed number 4 on that list.
Number 4.
You missed number 4 on that list, yeah.
Okay, yeah, we'll do
8,
that. Just
9,
remind me.
17.
Definitely remind me if I forget. I just want to spend a little bit of time checking if everyone's happy with base 5 before we switch up the base.
Of course, I just wanted to point it out
Yeah,
before
yeah.
I forgot it.
And I might forget, so please keep it in mind for sure. I don't see any questions on base 5, so I guess let's just go then. Yeah.
0.3. Is it supposed to end? Is the
Whoa,
answer
whoa,
supposed to
whoa.
be the
Hold on, hold on.
symbols?
You're super loud. I can
Because
adjust
when
that.
I look in the key, it's numbers.
Which problem?
Uh, problem. Oh, 7.3.
7.3. Let me go there. 7.3. Convert the following one-hand numbers to the Devanagari symbols. Okay, so let's do. Which one do you want to do? Maybe number 2 is the most mixed up one.
Yeah, okay.
So why not number 2? So that is problem. Oh wow, something is up with my program. No, it does work right. Okay. Sometimes it. Yeah. Okay. No, it was just me. What was that? 7.3, number 2. Number 2. So let me just copy this so I don't forget. We have a foot. We have 2 hands and a rock. So now, just in case someone needs it, we will make it super clear. So starting right to left, we have I'm just going to do it like this, number of rocks, number of fingers, number of hands, number of feet, and that's where we stop. So we have 1 rock. Whoop, that was not angled at all. Boop, boop, boop. Not very angled. No fingers, so a little 0 there. Sorry, this is just it's not acceptable. Get a little hook there. There we go. Then we have 2 hands. Curly. Did I put my 1 the right way around? Why am I paranoid now? Do it from memory. I obviously write these numbers all the time, right? Oh, I didn't. I did it backwards. That's why it felt so weird. I thought it felt super weird for a second. Terrible, teacher. Terrible. It's not like it's permanently on YouTube. Then I have number of feet, which will be another, let's get it nice and curly, 1. But you're right, the 1 and the 2 look very similar. Yeah, that's why I want that loopy there. And the 1 doesn't have a loopy. It's more question mark like. That's it. Yeah, that is it. That's all we need to do.
Key is
And then this will eventually become number of ones, number of fives,
I
number
think the
of
main question came
25s.
from
Yeah.
because the key was showing us it
Decimal
in
system.
in the decimal system
Oh,
instead of the written system. So
Yeah.
with
then we didn't. Not according to 7.3. Maybe I was
if you look
misreading
at your
it.
answer key, it shows the other system.
We're
Like
making the
you
answer
wrote
key
Yeah.
it
right now.
in decimal, even though you wrote it in that. So just look at your key afterwards, because other things
I
can also be
see.
confusing.
Yeah, yeah. So that could be
Yeah.
confusing.
Okay. That's super.
Right, right.
Thank you.
Okay. So we're not even fully converting it. We're actually just counting rocks and fingers and stuff.
Converting it to the symbols. Okay.
Yeah, so it's not even a full conversion.
Okay.
We could then,
I
uh,
thought I was missing something.
yeah, no, it's not the answer in
Okay.
the question doesn't match for sure. We could then convert this. I mean, why not? This would be now, some people like to set this up right to left, left to right. It doesn't really matter because I have what the group size is underneath. Maybe my, whoops, my S and my 5 maybe look too similar. So I'll just do it like that. We can start from any direction. So we could say here that corresponds to one group of 125. If we now convert it to a decimal number, plus two groups of 25, plus zero groups of 5, plus one group of 1, and then we'll get our answer, which is 175, 176. So that will be decimal. And then if we go here, this has the base 5 equivalent of 1, 2, 0, 1. I just have to write the 5 underneath to indicate we're counting in groups of 5. And all these things are, well, these first three are equivalent, that any one of them can be converted to decimal in sort of the same way. Yes, and then of course I want to be able to convert a decimal number back to any one of them. They're just sort of, through history, different versions of the same base 5 number system. Should we do the other conversion direction or not?
Yeah, could we go over the other ways?
So again, let's not take a problem that you have. Let's just make another one. Let's make an example. So now we're starting with a decimal number. Let's not make it super big. It's unnecessary. Let's say 12,731. Completely random. And of course, if there's no subscript, then that means it's a decimal number. Sometimes some problems or examples might have a 10 there just to emphasize the decimal number. That's just a decimal number. Okay. Then for consistency, again, I'm looking for consistency, trying to repeat strategies that I've seen before. And I've seen conversion of a base number when we did the Babylonian numbers. And what I did there was make a table. So maybe I want to do it again. My group size. Then, well, let's see, what's the group size here? Now I'm working in powers of 5. So what is the largest power of 5 that can fit in there? Maybe it'll take some trial and error, maybe some guessing. Let's try, I don't know, 5 to the 5. And we see that is 3,000. So let's try the next one. 5 to the power of 6. And we see that's 15,000 and I'm in the 12,000 range, so that was too much. Okay, so 5 to the power of 5 is my largest group, which is 3125. And then I have to go all the way down. 5 to the 4, 5 cubed, 5 squared, 5 to the 1, which is just 5, and then my 1s, which is 5 to the 0. Maybe you want to write that for consistency. So this is just 1, 5, 25, 125, 625. You memorize it after a while. Then I want to see how many times does that group fit. So for example, the first group size fits into 12,731 a certain number of times that I can find by division. 12,731 divided by, and we get 4 times and a little bit, not a lot. Then I want to see, okay, how much of my original quantity have I used? So 4 times 3125. And we see I've used 12,500. Ooh, I used a lot. I just made a random number here. And how much do I have left? Not a lot. That's simple enough to do, 231. So we see the similarity between this and the similar direction for Babylonian conversion, because that was a base 60 number. Makes total sense that we would use the same strategy. Our group sizes were just different. So now we have 231 left. That's too small for a 625. So no 625s can fit. I've used nothing extra. I still have 231 left. But some 125s can fit. But 2 of them will make 250, and I only have 231, so only 1 of them. And I've then used another 125, and I have left, a little 6. Not a lot. And you see I couldn't have even, no, not a 6, no, not at all a 6. I read 131. Let's put something in the chat for people to see. Not at all to check up on me. 106. So easy to make a little mistake. Then we can fit some 25s in. How many 25s can we fit into our 106 that is left? Since I've been talking for a while and you've said nothing. How many 25s can go into 106? 4 of them. And that uses 100. And now 6 will be left. I can still fit in a 5. I'm using 5 more, and only 1 is left, and that last little 1 will use it all. So then here I will have my decimal number conversion. These number of times that they fit is exactly the answer, 401,411 base 5. So we try and build on something we have seen. It's not quite the same. Group size is different, but the basic strategy is the same. How do we feel about that? Very similar, very similar. The smaller the base, the longer this list becomes, and it definitely becomes a little bit tedious. There's a simplicity to the higher base because my table will never get that big. You'll see base 60, I jump from 3,600 to, 216,000, which means my table will always be nice and small, but the division isn't as easy, and the arithmetic isn't something I can necessarily do in my head, so I don't know if I have a favorite. They're all the same. It's all the strategy, and then the answer just is what it is.
Is this work you would like shown on the test?
For the test, the issue mainly is you have to show something. And the less you show, if you happen to make a silly mistake, it becomes very hard for me to verify that you did know how to do it. If there's no real work shown or no detail and there's a mistake, then the assumption could be, well, I guess you have no idea what to do. And then I can't give you anything. So the more detail you show, the easier it is to give BART marks. That's really what it comes down to.
That makes sense. Thank you.
Now, it doesn't have to look like this. This is just some structure in case you have no idea what to do that you can rely on and know, okay, for this direction from decimal to another base, I know what I'm going to do. This is how I'm going to set it up, get some confidence. But this is certainly not the only way at all. I take the approach of what if I have no idea what to do? What is a way that has enough for me to make sense that I can look back and remember easily how it worked and so on. All right. So now, of course, you can then take this and write, can we squeeze it in here? Sure we can. You can take this guy and write any version of base 5 you want. Let me practice my 1 there. Let me practice it some more. And let me practice it one more time. Or you can go, oh, I don't want to go further, right? We didn't really bother with symbols past an elbow. No, what was it? A foot. Next could be an elbow, and then it gets a little silly. Because the original base 5, the one-hand system, wasn't really designed for large numbers. So you have to keep introducing new symbols for every new group of 5 or power of 5, and it gets a little silly. So let's not even bother with that. I honestly don't even know past elbow what they used. I don't really care. We get the gist and then build from that to something more elegant where I repeat the digits and the symbols. It's much, much more efficient. So luckily, people will realize this very soon. Like, whoa, this is not efficient to just keep introducing new symbols. The Romans sort of got around it with their line over strategy, but place value system is way more efficient. Regardless of the symbols you use, you cycle through with the same symbols, and there's no limit to how big your numbers can be. Way more efficient. Alrighty, where are we? Where are we? We've converted decimal to base 5. Next up is arithmetic. Now, if the arithmetic, now the same kind of thing is happening here in terms of testable questions when we compare it to Roman and Babylonian. We want to be able to do the same thing. We want to be able to convert back and forth. We want to be able to do all 3 of the arithmetic types, leave division, and that's it. There's no mystery question that you're not going to be ready for. The only, well, it's an upside and a downside. The upside is I'm counting in groups of 5. It's pretty basic in terms of my options per place. It's not like Babylonian. It's not like Babylonian where I have a ton of options for what could be in a place. In these base 5, regardless of what version I use, one-hand system, Devanagari symbols, my familiar digits, it's still the same. So the downside, unfortunately, is I have to do arithmetic, be able to do arithmetic in any one of them, but they're all the same. So let's get to it. Let's get to it. Assuming you want to talk about arithmetic, I mean, maybe it's too easy. Should we not even bother? No. Are there any modern cultures that commonly use anything other than decimal? No, I think these days with the I guess luxury of knowledge being and information being shared so efficiently, I think everyone realized very quickly that decimal is just that sweet spot between not too many symbols and still the representations aren't super long because my base is super small. It's a nice balance between the two. But if you go into other um, scientific requirements, I'll say, like technology, having to code things and program, then you have to switch to binary because you only can switch something on or off. You only have two options. So then you have to work base two and you don't have a choice. So outside of human communication needs, there are other bases. Uh, base base 16 has some benefits in technology and information and cryptology and things like that. But again, those are, I guess, in a way artificial. Some things are more efficient depending on your medium and your physical limitations. For us, no, decimal is a nice balance. Okay, so let us see addition.
Which base system will be
Whoa, that is
used?
super loud. Hold on.
Sorry.
No, you don't know. I can adjust it. I just don't know until it happens. Continue.
Which base systems will be on the test?
So we have our Roman, our Babylonian. Then that gets us through the first 3 pages. 1, 2, 3. There are 2 pages left. One page is for conversion from a base 9, or let's say 2 to 9, base 2 to 9, converting back and forth to and from decimal. And then the last page will be arithmetic in any base 2 to 9. We're not going to go over 10 because then we have to introduce more symbols. So we'll stay below 10. Just 1 second, I'll be right back. Volume on another TV is a little bit too loud. All right, I'm excited about this. I don't know why. Let's get it done. Now, let's go. We need all 3 versions of arithmetic, right, for base 5. So one hand system, let's get a hand in there, maybe a couple of hands. Let's get some fingers, and let's get a couple of rocks. Let's maybe have 3 rocks. We're adding. Let's put a hand in there, a couple of fingers, and a rock. Right. Now, you let me know how much time you need. These ones are quite basic, but if you need a minute, we can take a minute. But we have a fair number of them to do, so don't want to take too long. Now, I'll give time for the, I guess, more important ones. These ones are quite straightforward since you just merge the number of rocks into 4 rocks. There's not much to do here. Just watch out, you can't have 5 of the same symbol. And here I have 6 fingers, and that's a no-no. So 5 of those fingers merge into a hand. I have 1 finger left, 4 hands. Get a hand there. And I'm done. That's easy enough, I hope. Was that easy enough? Don't know. I don't want to assume something's easy and it's not. You have to speak up. Now, don't worry about the volume. I can adjust anyone's volume. Don't let that be a reason for you not to speak up. Anyone who has already spoken, your volume is now good. Don't worry. It's just I don't always know and you don't always know. It's all good. All right. Now, we switch it up. Still addition. Having the symbols be a little less familiar just makes me extra aware of what I am doing. And that's our purpose behind all of this. So let's go with 1. Let's go with maybe a 4 symbol there. And now we recycle these symbols. We're not limited to the size. So let's go maybe 4 of them. Let's go another 4. And let's go, oh, I haven't done a 3 yet. Nice and curly. Oh, I like that 3. That's a good 3. Plus, let's go nothing here. Let's go 3 again. And let's maybe make 2. Trying to map my 1 and my 2 different. And let's go 4 again. There we go. Let's take some time with this one. Now the numbers are small, so the arithmetic is something I can do in my head very easily. So we don't need that much time. But let's take, this is our first one. Let's take a couple of minutes just to be sure. All right, I mean, I don't know exactly how much time you guys need, so let me know if that was too much or too little, or I don't know. You tell me, it's your session. The goal here, like before, of course, in a test situation is to stay in this, not decimal at all. I'm going to leave the conversion to you, so I don't get into a bad habit of even thinking about converting this. There is no conversion for me. But you can certainly convert this, assuming your conversion is correct, and then double check it. Yeah, it's an option, but you have to make sure your conversion is correct. All right, so right to left, written arithmetic, nothing changes in the method. 3 plus 4 is 7. Now let me know if I need to repeat something here because it's all done without writing anything down like it would be in the actual decimal method. 3 plus 4 is 7. 7 is one group of 5 and 2 left over. Yes? Maybe? Sometimes? If I say so, I guess? No? Any reaction? I know you're speechless.
Yeah, that sounds right. That looks right.
Okay, good. I'm usually right, yes. That doesn't help you. Then I have 1 plus 4 is 5 plus 2. Oh, it's another 7. All right. Carry over one group of 5, which becomes 1 in the next, which is one group, and 2 left over. Fine. It was a random example. Then I have 1 plus 4 is 5, plus 3 is 8. That is one group of, make my 1 a little bit longer to help me tell it apart from, I don't know if that's better. That doesn't look better. That's not better either. Now I'm becoming obsessed with this. I'm just gonna let it go. And then I have, whoops, that's not right at all. Then I have, there's a delay sometimes in my pen and I don't know what I did here. That's my excuse, I'm sticking with it. And 2 left, of course. Now, whether we do it this way or say 1, 4, 4, 3 base 5 plus 3, 2, 4. See, is a delay in my pen today. It's the same thing. There's no difference between the two. 3 plus 4 is 7. That's one group of 5 and 2 left over. 1 plus 4 plus 2 is 7. That's one group of 5, 2 left over. 1 plus 4 plus 3 is 8. That's one group of 5, 3 left over. 1 plus 1 is 2. There's no difference between the two. But it's sometimes nice to write stranger symbols to really focus on the method and not fall into familiar situation where my thinking is sort of shut off out of habit. So if we can do the Devanagari symbols, then the modern version is exactly the same. Exactly the same. So there's almost no benefit. I just need to do this way and it's super easy. The symbols just change, nothing else matters. But we can do them in parallel and you'll see it's always going to be the same. Subtraction. Actually, no. Multiplication. Multiplication. Okay. No, maybe I like to do multiplication next because it's closer to the to addition than subtraction in a way, in terms of the appearance of the method. Now we can do one hand, sure. Let's get it done. Let's make a hand. Let's make a couple of fingers. Let's make a couple of rocks. And we're going to multiply by, what do you want to multiply by? Again, we're going to have it a single space. So what I'm multiplying by will only be rocks. How many rocks do you want to multiply by? It's a little deceptive because it's not really rocks. It's more of a concept. 3 rocks. It's not really rocks. It's more the concept of duplicating this a certain number of times, which is why I don't love these old representations, but whatever. 3 times 2 is 6. 6 will be one finger and a rock. I don't have an empty place symbol, much like the Roman numbers, so I move over. I'm going to start in the second column because I'm multiplying with the second portion of the number. 3 times 3 is 9. 9 will be one group of 5 and 4 left over. Then I'm going to multiply by the third column. 3 times 1 will be 3 hands, and I'm ready to add. Right to left, rock. Ooh, I have 5 fingers here. That becomes a hand that I'll sort of put over there with nothing. I'll preserve my spacing in my columns, and then here I have 5 hands, and that will become a foot. Now, of course, you can merge them. The spacing doesn't mean anything, but just to keep everything in line, I'll keep the spacing to help me keep track of everything. So, I mean, it's almost Roman in a way. It has a Roman feel to it for me. In that I don't have empty placeholder symbols. I have duplicated symbols. Yeah, it's a little Roman-esque. But there it is. All right, sticking to multiplication. Now we don't have any size limitations. Let us see. Let's make 3. Why am I writing so small? Let me make it bigger. Maybe a 4 there. Maybe a 1. Maybe another 4. Just okay. I'm just checking. My 6-year-old has a class, and I'm not sure if she knows what she's doing. Anyway, what do I multiply by? Again, single-digit number. My options are 1, 2, 3, or 4, which makes this so convenient. Like the multiplication will be something I can do in my head. Makes it easier than the Babylonian system for sure. What do you want to multiply by? Do you have any strong feelings towards a number? Anything comes to mind? Any preference? 4. Again, very few options here. And obviously we're not going to do a 1. That'd be silly. So our options really are 2, 3, and 4, which makes this much easier than you might think originally. Then, okay, 4 times 4. Okay, my numbers are a little bigger. Fair enough. 4 times 4 is 16. So now I have to split that up into groups of 5. 16 will make 3 groups of 5. That's not a very pretty 3, but I'll go with it. 3 groups of 5 and 1 left over. Now I'm going to the second column there. So at least I have a 0 to pad it with. Next, 4 times 1. Oh, it's nice and easy. 4. Then I'm going to go to the third column, pad with 2 zeros. 4 times 4 again, 16. That will be 3 groups of 5 with 1 left over. Now I'm going to go to the fourth column, pad it up. 4 times 3, finally something a little different. That is 12. 12 will be 2 groups of 5 and 2 left over. Then let me shift this up. Hold on, I'll be right back again. I know how to do it. All right, let's do it. Then we have a 1. Whoopsie, that's an ugly one. 1. There's a little carryover. Yay! 3 plus 4 is 7. That's exciting times. That'll be 1 group of 5, 2 left over. Then I have 2 here. Then I have 3 and 2 make 5. And nothing's left over. 1 and 2 make 3. Now, whether I do it this way or whether I say 3, 4, 1, 4, base 5 times 4, nothing is different. Absolutely nothing but the appearance, the symbols that I'm writing. So if you can do one, you can do the other. How do we feel about multiplication?
Sorry, just to clarify, so if it's 3 plus 2 or like 4 plus 1, it's going to be 0 and then carry the group of 5 over to a 1?
Yes, whenever I have a 5,
Okay.
it merges into one thing of the next column.
Okay, thank you.
Because everything is in groups of 5. Yes, yes. Any other questions or thoughts? Well, then I guess subtraction's left. Boom, boom, boom. Whoops. All right, since we're going to see this again with other bases, I'm going to make the subtraction medium, and we can step it up next time when we mix up the bases a little bit. All right. Mid-range, right? Mid-range. Let's go. Oh, we want to do one hand one. Yeah, let's do it. Let's make 2 hands. Let's make a finger. And let's make 2 rocks. Ooh, here's a good one. Then let's subtract 4 fingers and 3 rocks. Yeah, I like it. Yeah, let's do it. Or do we need some time? Yeah, we need some time for this one, I think. Let's take a minute, see how well do you know the subtraction method. All right. Maybe that was too much time, but first subtraction. All right. So 2 minus 3 can't be done. I'm going to borrow. Let's get some color in here. I'm going to borrow 1. I'm going to take this guy. And that splits into 5 rocks. That finger's gone. I now have 5 rocks, not plus the 2 that were there, so 7 rocks minus 2. What am I saying? 7 minus 3 is 4. And I have 4 rocks. Now in the second row there is currently nothing. Which means I have to borrow. What am I going to borrow? I'm going to borrow 1 of those hands, and that becomes 5 fingers. That hand is gone. I then have the 5 fingers with nothing that was there, minus 4. 5 minus 4 is 1 finger. And I have 1 hand minus nothing. Done. Is that what you got as well? Good. If you did it, pat on the back. Good job. If you didn't, now at least you have something to work from, and maybe you can, hopefully you can identify what went wrong and where. Now we should step it up to a little bit more evolved symbol system. So let's make up one. Am I in black here? Yes. Let's go. Let's go 4. Why not? Let's go 0. Let's go 2. And let's go 1. Take away. Let's go 3. Let's go 1. And let's go 4. There we go. Why not? For this one, let's just give a minute. It's a more efficient version of the base 5 system, so it should be easier. Let's take a minute though. All right. Let's do it. So we have 1 minus 4. Can't be done. I'm going to have to borrow. Let's get my borrowing color. I'm now going to borrow 1. And that then updates to 1. And now here, this is where we don't have a symbol for 5. So to make this as obvious as possible, my recommendation is just make 5 little rocks. That's still consistent. That's still in the system. We're not writing decimal numbers. You can't write a 5 there. There is no 5 here. We do split this open and get 5 little things. 5 rocks. Why not? Whoa.
Would it be wrong if we drew like 5 like 1 symbols?
No, I think that's fine too. We're
Okay.
still staying in that system.
Okay.
Technically, you have to write 1 0, but that just creates confusion in my experience, and I don't think it's necessary to do. So as long as you don't write the decimal number 5, you're gonna be okay.
Okay.
So now we have 6 here because the pink 5 and the 1 that was there will make it 6. 6 minus 4 is 2, and we write our 2. That looks too decimal. Maybe a little better. Now on to the second column. 1 minus 1, perfect. 0. Third column. 0 minus 3, nope, not gonna work. I always borrow 1. Then this updates to 3. What do I have? This 1 that I borrow splits open into, I guess you could draw 5 little hands here. Or you can draw 5 1 symbols. That's okay too. Just don't draw the number 5. There's no number 5. Then I have just 5 because there was nothing. So just 5 minus 3 is a 2. 2 here. And then 3 minus nothing is a 3. Write it like this. Write 4, 0, what was it, 2, 1, base 5, minus 3, 1, 4, base 5. It's the same thing. Exactly the same. Now we just want to show, like I did with the blue and the pink here, how the method works. So you don't want to show nothing because then I can't verify if you're using the method. Maybe you just converted it in the background and converted it back, and that's not what the question is asking. So we want to show some work, and we can show a little more with these ones, that you understand the borrowing that occurs. You want to really highlight that borrowing so that your answer sort of stands on its own, showing that you understand what to do. So I'm not going to repeat the whole borrowing thing. It's exactly the same. It's exactly the same. Any questions on this subtraction? Same method, Roman, Babylonian, it's all the same. Same method, which is why we're doing them.
So in the test, we only have to show like the subtraction on the left side. The right side is just like if we want to, or do we have to show both?
No, I'm saying regardless of how the question is phrased, which symbols is still base 5. You would do exactly the same with your borrowing and your everything would be exactly the same.
Oh, okay.
I'm just not duplicating it because we just did it. What we have on the right here, these are not decimal numbers. The question could be phrased like this, or
Okay.
it could be phrased with different symbols. Still base 5, you do the same thing. I just
Okay.
didn't want to duplicate what we just did. No. The decimal conversion to and from, we started with that. That will be page 4. They're separate. We're not going to mix conversion questions with arithmetic questions because the whole point is to not convert and focus on the method. So there will always be separate. And then really the only thing that is left is to mix up the base. And for that, we will stick to these modern symbols. So if my base changes, then my options for the digits change accordingly. Always going up to 1 less than the base. So base 5, my symbols go up to 4. Base 9, for example, my symbols go up to 8 because it's a different system, but I'm working with familiar symbols because why introduce a whole bunch? We memorize a few, but I didn't feel it necessary to ask you to memorize all of them when they're arbitrary. I could have chosen a different century. So it wasn't really the point to memorize a whole bunch of uh, symbols that were used at one point in time. So we see here with the other bases, we want to be converting back and forth, and we want to do our 3 arithmetic methods. The base could be 2 to 9, and we don't know which one it's going to be. We don't know exactly the question, so we want to prepare for them all. So we can quickly do 2 conversions. Let's just randomly pick one. 3, 5, 2, base 8. When I convert that, well, now I have to remember, maybe it's nice to write it down. These will be the number of ones, we'll say. These will be the number of 8, groups of 8. These will be number of 8 squared, which is of course 64. So this will then correspond to, if we write left to right, 3 groups of 64 plus 5 groups of 8 plus 2 groups of 1, or just leftovers. Let's give MathBot something to do. 3 times 64 plus 5 times 8 plus 2. Though I'm sure you could have done that in your head, of course. Why not? Back it up with calculator, verify. 234. So that one is certainly more straightforward, but I see people mix it up. Make sure you understand the way you're going to convert. And the different directions have different methods. If now I say maybe 1273 into base, what base do you want? Doesn't matter to me. Pick a base, any base. 6. All right. I know my method. I go in knowing the method. When I'm going from decimal, I am going to pick my group size, I call it. And now I have to find the highest power of 6. I don't know my powers of 6 that high necessarily. I'm going to try 6 to the 4. Oh, that is very close. Wow. Sadly, too big. I overshot it a little bit. That was 6 to the 4, so my largest one is 6 cubed. Then I have to go all the way down until 6 to the 0, which is of course 1. Next one is 6. Next one is 36. 6 cubed. Maybe you know it, maybe you don't. You certainly don't need to. 216. It's a little bit more convenient for me to use 216 instead of 6 cubed, but it really doesn't matter. Then how many times can it fit is what I want to know. Ooh, that's a wobbly line. 6 cubed, 216 can fit into 1273. How many times? MathBot says 5 times. How much have I used? Well, 5 times 216. I know you can do it in your head. I want just something to see in the chat box. $1,080. And what is left? Subtraction from the original. Whoa, I did something bad here. Hold on. Something happened. Something bad happened. Hold on. Hold on. What on earth is going on? Let me just write a message. Something happened in Discord. Everything's bad. Everything's just bad. Something happened that Discord did not like. Let me try and get this back here. Come on, so many windows. Close the windows. Discord is an unhappy camper now suddenly. Don't even know if you could see this. I think you can see it. Something is just not going well. Hold on, let me. Not sure if you can hear this at all. Okay, are we back? Can you still hear me?
Yes, we can still hear
Oh,
you.
something just went crazy. Okay. I think we're okay. So I don't know what happened there. I was pressing something. All right, we're back. Okay. Then we have left. Did we actually do that? No, we did not. Okay. We have left 193. And you see, yeah, it was too small for another 216 to fit. But I can fit some 36s. How many times can I fit 36 in there? So that's a division, 193 divided by 36. And we get 5 times. Oh, 5 again. 5 times 36. I can do some things in my head. 5 times 30 is 150 plus 5 times 6 is 30, so 180. And then we have a measly 13 left. Then I can fit 2 6s in there using 12, leaving me with 1 that the last position can mop up. So that would mean that my number is 5, 5, 2, 1, base 6. But I go in knowing, okay, I know what I'm going to do when this is the conversion they're asking. I have confidence in my method, and it'll guide me to the answer. And then next up, we have to do some arithmetic, one of each, addition, subtraction, and multiplication. I think my computer needs a restart. It's a little bit slow. Addition. You can pick a base while I write some digits. Oh no, I need to know the base before I can write the digits, right? You pick a base, any base. What should we do our addition in? And we'll make it as hard as possible, I guess. 7 it is. You can think for the other ones in the meantime. But let's do a 7. Let's go 6, 5, 2, 6. Base 7. And I'm adding. Let's add 3, 3, 4, 5. I know, not very original. 5. All right. Now, we don't have a lot of time, but we can take a minute, I think. Addition's the easier one of the group, but just in case someone needs it, we can take a minute. I just realized I didn't even put the timer on the screen. If you're watching on YouTube, then you would see a timer. Oh man, what am I doing today? All right, 6 plus 5 is 11. 11 is way too much. 11 is one group of 7 and 4 left over. 1 plus 2. 1 plus 2 is 3 plus 4 is 7. Oh, it's perfect. One group of 7, nothing left over. 1 plus 5 is 6. 6 plus 3 is 9. That's one group of 7 and 2 left over. 1 plus 6 is 7 and 3 is 10. That's one group of 7, 3 left over. Done. And not to take away from your possible struggle, but once you get the hang of it, because the method is always the same, we could have done, no, we can't, yeah. It's always the same. We could have done this in a different base. You just have to keep track of your group size. That is the most important thing. What is the group size? And keep that in mind as you go. All right, multiplication. And of course, if everything, if anything went too fast, the video is always going to be on YouTube. You can go back, watch it over and over and over, laugh at my technical inadequacies, whatever you want to do with it.
Steven,
Pause it at any time. Yes.
could we do the question 17 for the multiplication? I put it in the
Yep.
chat. It's 84 times 7 with a base of 9.
I see it. Now, just as a reminder, that is not 84.
Sorry, 84.
But
I was just
I know
saying
what you're meaning. Yeah. Can we
yeah,
make it a
I
little bigger
apologize.
though? Can we put a little extra digit here? Is that okay?
Sure, I was just trying to figure out if I got
Like a
it.
3?
Yeah,
Sure.
go
It's
for
not
it.
gonna.
It won't change.
No, not really. No.
Thank you.
Times 7, and we're in. Whoops. Base 9. Yeah, it's not gonna really affect the part you did. 7 times 4 is 28. That will be 3 groups of 9 for 27, 1 left over. Then I'm padding it with a 0. I write my 9 so I don't forget. I'm multiplying 7 times 8. 7 times 8 is 56. Breaking that up into groups of 9. How many groups of 9? I pretend to think so you can answer. This is awkward. Someone say something.
6.
6. Yes, thank you. That 6 goes over here. That accounts for 54, so 2 left. Now I'm going to go to my third column. So I'm padding with a wobbly 0 there. 7 times 3 is 21. 21 will be 2 groups of 9 for 18 and 3 left over. And then I'll add them all up. 1, 5, 9. No, because I'm in base 9. There is no 9 symbol. Whoops. That's a group of 9 going over with nothing left and a 3. And you'll be surprised how quickly and easily a little mistake like that can happen. Very easily done. All right, multiplication. I did not give you much time to do that at all because it was I guess it was a problem. So I assume you would have done it before. But for our subtraction, we can give some time and maybe actually show the timer. That would be me actually doing my job. Come on, new page. There we go. Okay, what is our base for the subtraction? Possibly last question. What base can it be? What can it be? No, no one wants to pick a base. Contribute, take part. It's way more fun. No, no one. All right. 8. Yeah, I wanted it to be big. Oh, sorry, you were close. Next time, save that 3. 8. Let's make it 2 and a 0, and maybe a 1 and a 0. Haven't we done 8 already? I can't remember. Oh well. In the conversion we did, yeah. Minus. Let's go with a 5 and a 7 and a 6. All right. We have time. Why not? Take the time, see what you can come up with. We'll stick to our 2 minutes. But if you need more after the 2 minutes are done, this is an important one, so let me know. Actually, I haven't started the time yet. I'm going to make it 3. All right, last question for the day. Maybe. Does anyone need more time? Let me just ask that first. Are we good to go? Good to go. All right. So let's get some color here. Color makes everything better. 0 minus 6? Nope, not happening. Take that 1. Well, take 1, and I only have 1. To borrow, what do I write here? You can't write 8, so you can decide. I'm just going to make 8 little dots. It really doesn't matter. You can make 8 little lines. You can make 8 little squiggles. I don't care what you make, as long as you don't write the decimal number 8, because that is not in this system. Then with the 0 that was there, we have 8 minus 6. 8 minus 6 is 2. Now that guy is gone, right? Now I have nothing. I should update that to a 0. 0 minus 7? Nope. So I go and borrow. There's nothing to borrow. So I go and borrow from the 2. Let's get another color. Let's go blue. Blue it is. So then I go borrow, updating that to a 1. I borrow 8 things. What you use to represent those things, that is completely irrelevant. I know if you think of the one-hand system, that is not the rocks column. It's the hand column. I don't care. It's just 8 things when I split open the baggie. But that's not where I'm at. I am trying to borrow for the second column from the right. So let's get a nice green going. We can certainly do decimal calculations in our head, for sure. I mean, how can we not? You just have to be careful what you write. So now I'm going to have to zoom in on this. Potentially cutting into my webcam, but whatever. Now I'm going to borrow this guy. Come with me. And that splits into 8. With the 0 that was there. I like this one. This is nice. I have 8 minus 7, 1. Now that guy's not there anymore. He's gone. So I have 7 left in the blue rectangle. 7 minus 5, 2. 1 minus nothing, 1. Let's zoom back out. The bigger question is that what you got as well? And if not, then that's okay. That's why we're doing this. Try and isolate and pinpoint what went wrong. What am I doing? How can I do that? And come up with you have a little bit of flexibility, right? I choose the dots. Come up with whatever you want to come up with. Just don't write a decimal number. That is the most important thing. So there's a little bit of flexibility, but be consistent. Always do the same thing in a way that makes sense to you and is clearly following the method.
Stephen?
Yes.
As a last question, just to make sure, for Friday's quiz, this is the last new material that will be on there, correct? Tomorrow's material,
Yes.
Thursday's material will be on the next quiz?
Yeah, there's a delay for sure. Otherwise, we wouldn't have been able to fit everything in. So this is where it ends. Really, the only thing that Chapter 8 is not actually anything new. Chapter 8 is just specifically talking about base 2 numbers, which is among the ones we should practice anyway. But you don't have to look at Chapter 8 if you want to sort of minimize the actual things you think about, but do practice a base 2 number and see the ones in the zeros becomes a little tricky to do by hand. And that's the only
Okay.
thing. So it's not
Thank
really
you.
a new chapter. Yeah. So we start with Roman numbers. We end with any base 2 to 9. But I didn't want to put the test tomorrow because it feels way too close. When do you actually study? I don't know. It doesn't feel right. So I put it on Friday in case you need the time. But the downside is that there's an overlap. We start new stuff while still thinking about a test. There's no perfect solution. All right, that will be it. Uh, as you're studying and you still have questions on this, luckily we have the time. The test is on Friday, not tomorrow. Check the course website, check the description in your course chat on Discord. Ask questions if you have any. And I will see you guys later. Actually, I won't see you. I'll hear you later. Until then.